Hi, I'm Al, and I'm here to tell you a little bit about Newton's second law. Newton's second law states force equals mass times acceleration. How fast an object accelerates depends on the force pushing it. Pushing or pulling an object produces acceleration. An acceleration is a change in the speed of motion. An acceleration can be a slowdown or a speed up. The heavier the object, the more force it takes to make that object speed up or slow down. In this picture, you can see that this young gentleman has a very heavy rock. This gentleman has a much lighter rock. This gentleman right here has to use a much greater amount of force to accelerate this rock across the table, whereas this young man does not have to use as much force. This young lady right here seems to appreciate all this young man's hard work. Another way you can think about Newton's second law is it takes much more of your strength to push a bowling ball with one foot than it does to push a marshmallow with that same foot. So now we're going to get into our first example. For all you Tigers fans out there, how is Justin Verlander able to throw a 100-mile-an-hour fastball? Well, this can be explained by Newton's second law. The object is the baseball. The mass of that baseball is 6 ounces. The force is Justin's arm, and he's able to accelerate the mass of that baseball with such an incredible amount of force. If the mass changed, if say the mass of the baseball was 40 pounds, he would not be able to accelerate the baseball with the same amount of force. And for a little bit extra information, the average high school baseball player can only throw a baseball about 80 miles an hour. So that just tells you the amount of force that Justin's able to create on that ball. So now we have a homemade example of Brock and myself.
You've got a friend in me. You've got a friend in me. When the road looks rough ahead and you're miles and miles from your nice warm bed.
So a little bit about the science behind our little experiment. When I was pulling Brock in the first trial, I did not have to use as much force to be able to accelerate him at an average speed. In the second trial, we added about 40 pounds to the weight that I was pulling, and I had to use a much greater amount of force, and I was not able to accelerate Brock in the chair at the speed that we were able to create before. A real-life application of Newton's second law is, as the price of gas is increasing, people are trading in their trucks because it takes much more force to power their heavier trucks than light cars. The price of gas is astronomical these days, and a little physics can show us that the lightweight car is a better choice. Thanks. That's a little bit about Newton's second law. Now we're going to turn it over to Carrie for Newton's third law.